The Northrop McDonnell Douglas YF-23 is an American single-seat, twin-engine stealth fighter technology demonstrator prototype designed for the United States Air Force. The design team, with Northrop as its prime contractor, was a finalist in the United States Air Force Advanced Tactical Fighter Demonstration Validation Competition, battling the YF-22 team for full-scale development and production. 2 YF-23 prototypes were built. In the 1980s, the United States Air Force began looking for a replacement for its F-15 fighter aircraft to more effectively counter emerging threats such as the Soviet Union's advanced Sukhoi Su-27 and the Mikoyan MiG-29. Several companies submitted design proposals. The United States Air Force selected proposals from Northrop and Lockheed for demonstration validation. Northrop teamed up with McDonnell Douglas to develop the YF-23, while Lockheed, Boeing, and General Dynamics developed the YF-22. The YF-23 was stealthier and faster, but less agile than its competitor. After a 4-year development and evaluation process, the YF-22 team was announced as the winner in 1991 and developed the F-22 Raptor, which first flew in 1997 and entered service in 2005. The United States Navy considered using a naval version of the ATF as a replacement for the F-14, but these plans were later canceled due to cost. After flight testing, both YF-23s were placed in storage while various agencies considered plans to use them for further research, although none proceeded. In 2004, Northrop Grumman used the second YF-23 as a display model for its proposed regional bomber aircraft, but this project was dropped because long-range bombers were required. The two YF-23 prototypes are currently exhibits at the National Museum of the United States Air Force and the Western Museum of Flight, respectively. American reconnaissance satellites first spotted the advanced Soviet Su-27 and MiG-29 fighter prototypes between 1977 and 1979, which caused concern in the U.S. Both Soviet models were expected to reduce the combat and maneuverability advantages of contemporary U.S. fighter aircraft, including the newly introduced F-15 Eagle and F-16 Fighting Falcon. Additionally, U.S. tactical air power would be further threatened by new Soviet systems, such as the A-50 Airborne Warning and Control System, revealed in 1978, and more advanced surface-to-air missile systems. In 1981, the USAF began developing requirements and discussing with aerospace industry on concepts for an advanced tactical fighter, with both air-to-air and air-to-ground missions in consideration. The ATF was to take advantage of emerging technologies, including composite materials, lightweight alloys, advanced flight control systems, more powerful propulsion systems, and stealth technology. The United States Air Force released the ATF request for information in May 1981 to several aerospace companies on possible features for the new fighter. Eventually codenamed Senior Sky, quote-unquote, the ATF at this time was still in the midst of requirements definition, which meant that there were considerable variety in the industry responses. Northrop submitted 3 designs for the RFI, ranging from ultra-low cost to highly agile to low observable missileer. All were on the small and light end of the response spectrum. In 1983, the ATF System Program Office, SPO, was formed at the Wright-Patterson Air Force Base from the initial concept development team. After discussions with aerospace companies and Tactical Air Command, or TAC, the CDT SPO made air-to-air combat the primary role for the ATF, which would replace the F-15 and emphasize outstanding kinematic performance with supersonic cruise and maneuver. Northrop's response was a Mach 2 fighter design designated N360 with delta wings, a single vertical tail, and twin engines with thrust vectoring nozzles and thrust reversers. Around this time, however, The SPO would begin to increasingly emphasize stealth for survivability and combat effectiveness due to very low radar cross-section. Results from the Air Force Black World, quote-unquote, innovations such as Blue F-117, Tacit Blue, and Advanced Technology Bomber, the ATB program, which would result in the B-2. Northrop was able to quickly adapt to the ATF's increasing emphasis on stealth. Since October 1981, a small team of engineers under Rob Sandusky within its ATB B-2 division had been working on a stealth fighter design. Sandusky would later be the Northrop ATF's chief engineer, while fellow B-2 stealth engineer Yu-Ping Liu was recruited in 1985 as the chief scientist. 3 design concepts were studied: the Agile Maneuverable Fighter, AMF, similar to the N-360 with 2 canted vertical tails and the best aerodynamic performance of the 3 whilst having minimal stealth, Ultra Stealth Fighter that emphasized maximum stealth through the edge alignment with only 4 RCS lobes and nicknamed Christmas Tree, quote-unquote, for its planform shape, and High Stealth Fighter that balanced stealth and maneuverability with diamond wings, all moving V-tail, rudder vaders, or butterfly tails, engine exhaust troughs, and aligned edges. HSF would take many design cues from the B-2 to reduce its susceptibility to radar and infrared detection, and Liu's understanding of both radar signatures and aerodynamics would lend itself to key design features such as the shaping of the nose, nicknamed the quote-unquote platypus, for the initial shape and pronounced chine edges. The canopy with their Gaussian surfaces. By 1985, the HSF had evolved to be recognizably similar to the eventual YF-23 and emerged as the optimal balance of stealth and aerodynamic performance. By November 1984, concept exploration had allowed the SPO to narrow its requirements and release the Statement of Operational Need, which called for a 50,000-pound takeoff weight fighter with stealth and excellent kinematics, including prolonged supersonic flight without the use of afterburners or supercruise. That's what that's considered. In September 1985, the United States Air Force issued a request for proposal for the demonstration and validation to several aircraft manufacturers, with the top 4 proposals later cut down to 2 to reduce program costs. Proceeding to the next phase, in addition to ATF's demanding technical requirements, the RFP also emphasized systems engineering, technology development, plans, and risk mitigation. The RFP would see some changes after initial release, following the SPO's discussions with Lockheed and Northrop regarding their experiences with the F-117 and B-2. All aspect stealth requirements were drastically increased in 1985. The requirement to include the evaluation of prototype air vehicles from the 2 finalists was added in May 1986 due to recommendations from the Packard Commission, a federal commission by President Ronald Reagan to study the Department of Defense procurement practices. At this time, the United States Air Force envisioned procuring 750 ATFs at a unit flyaway cost of $35 million in fiscal year 1985 dollars. Furthermore, the U.S. Navy, under the Navy Advanced Tactical Fighter, or NATF program, eventually announced that it would use derivatives of the ATF winner to replace the F-14 Tomcat and called for the procurement of 546 aircraft. Northrop's early work on the HSF would pay off for the Demonstration Validation RFP. By January 1986, the HSF would evolve into Design Proposal 86E. As a refined and well-understood concept through extensive computational fluid dynamics simulations, wind tunnel testing, and RCS pull testing, and became Northrop's preference for its ATF submission. Furthermore, Northrop's ability to design and analyze stealthy curved surfaces stemming back to its work on the Tacit Blue and the ATB B-2 gave their designers an early advantage, especially since Lockheed, the only other company with extensive stealth experience, had previously relied on faceting as on the F-117 and lost the ATB to Northrop as a result. That loss, along with poor aerodynamic performance of their early faceted ATF concept, forced Lockheed to also develop designs and analysis methods with curved, stealthy surfaces. Northrop's HSF design would be refined into DP-110, which was a submission for the Demonstration Validation RFP. In July 1986, proposals for the demonstration validation were submitted by Lockheed, Boeing, General Dynamics, McDonnell Douglas, Northrop Grumman, and North American Rockwell. The latter two dropped out of the competition shortly thereafter. As the contractors were expected to make significant investments for technology development, companies forming teams was encouraged by the SPO. Following proposal submissions, Northrop and McDonnell Douglas formed a team to develop whichever of their proposed designs was selected, if any. Lockheed, Boeing, and General Dynamics formed a team with a similar agreement. Lockheed and Northrop, the two industry leaders in stealth aircraft, were selected as finalists on 31st of October 1986 for the demonstration validation as first and second place, although the approaches to their proposals were markedly different. Northrop's refined and well-understood design proposal was a significant advantage, especially in contrast to Lockheed's immature design. But the Lockheed's proposal focused on systems engineering rather than a point aircraft design actually pulled it ahead. Both teams were awarded $691 million in 1985 dollars and given 50 months to build and flight test their prototypes. Pratt & Whitney and General Electric were contracted to develop the engines designated YF-119 and YF-120 respectively for the ATF engine competition. Because of the late addition of the prototyping requirement due to political pressure, the prototype air vehicles were to be quote-unquote best effort machines not meant to perform a competitive fly-off or represent a production aircraft that meets every requirement, but to demonstrate the viability of its concept and mitigate risk. As one of the winning companies for the demonstration validation proposals, Northrop was the program lead for the YF-23 team with McDonnell Douglas, and the two had previously collaborated on the F-18 Hornet. In addition to the government contract awards, the team would eventually invest $650 million, $1.45 billion in 2023, combined into their ATF effort. General Electric and Pratt & Whitney, the two engine companies, also invested $100 million, or $222 million in 2023 each. Airframe fabrication was divided roughly evenly, with Northrop building the aft fuselage and empennage in Hawthorne, California, and performing the final assembly at Edwards Air Force Base, while McDonnell Douglas built the wings and forward fuselage in St. Louis, Missouri. Manufacturing was greatly assisted by the use of computer-aided design software. However, the YF-23 design would largely be a continual refinement from Northrop's DP-110, with little influence from McDonnell Douglas's design, which had swept trapezoidal wings, 4 empennage surfaces, and a chin-mounted split wedge inlets, and did not perform well for stealth. The YF-23's design evolved into the DP-117K when it was frozen as the prototype configuration in January 1988, with changes including a sharper and more voluminous nose from the earlier Platypus, shape for better radar performance with a straightened aft deck lower drag shaping. Due to the complex surface curvature, the aircraft was built outside in, with the large composite skin structures fabricated first before the internal members. To ensure precise and responsive handling, Northrop developed and tested the flight control laws using both the large-scale simulator as well as a modified C-131 named in the Total In-Flight Simulator, or TIFS. Throughout demonstration validation, the SPO conducted system requirements reviews, where it reviewed results of performance of cost, trade studies with both teams, and, if necessary, adjusted requirements and deleted ones that added substantial weight or cost while having marginal value. The ATF was initially required to land and stop within 2,000 feet, or 610 meters, which meant the use of thrust reversers on their engines. In 1987, the United States Air Force changed the runway length requirement to 3,000 feet or 910 meters, and by 1988, the requirement for thrust reversers was no longer needed. This allowed Northrop to have smaller engine nacelle housings with the space between the filled in to preserve area ruling and subsequent design refinements for the YF-23 full system design, or Preferred System Concept, PSC. As the DP-117K had been frozen by then, the nacelles, nicknamed bread loaves for their flat upper surface, were not downsized on the prototypes. The number of internal missiles with AIM-120A as the reference baseline was reduced from 8 to 6. Despite these adjustments, both teams struggled to achieve 50,000-pound takeoff gross weight goal, and this was subsequently increased to 60,000 pounds. While engine thrust was increased from 30,000 class to 35,000. Aside from that, 35,000 pounds of force, right? 35,000 pound force, 165 kilonewtons, or 156 kilonewtons. Aside from advances in air vehicle engine design, the ATF also required innovations in avionics and sensor systems with the goal of achieving sensor fusion to enhance situational awareness and reduce pilot workload. The YF-23 was meant as a demonstrator for the airframe and propulsion system designed, and thus did not mount any mission system avionics of the PSC. Instead, Northrop and McDonnell Douglas tested these systems on the ground in airborne laboratories, with Northrop using a modified BAC-111 as a flying avionics laboratory, and McDonnell Douglas building the Avionics Ground Prototype, AGP, to evaluate software and hardware performance and reliability. Avionics requirements were also the subject of the SPO SRRs with contractors and adjusted during the demonstration validation. For example, the Infrared Search and Track, or IRST, sensor was dropped from baseline requirement to provision for future addition in 1989. Formally designated the YF-23A, the first aircraft, serial number 87-0800, Prototype Air Vehicle 1, PAV-1, was rolled out on the 22nd of June 1990. PAV-1 took its 50-minute maiden flight on the 27th of August with Chief Test Pilot Alfred Paul Metz at the controls. The second YF-23, or PAV-2, made its first flight on the 26th of October, piloted by Jim Sandberg. The first YF-23 was painted charcoal gray and was nicknamed Gray Ghost. The second prototype was painted in 2 shades of gray and nicknamed the Spider. PAV-1 briefly had a red hourglass painted on its ram air scoop to prevent injury to the ground crew. The red hourglass resembled a marking on the underside of a Black Widow Spider, further reinforcing the unofficial nickname Black Widow 2, given to the YF-23 because of its 8-lobe radar cross-section plot shape that resembled a spider. When Northrop management found out about the marking, they had it removed. A proposed naval variant of the YF-23, sometimes known as the NATF-23. The design was never formally designated, was considered as an F-14 Tomcat replacement. The original YF-23 design was first considered, but would have had issues with flight deck space, handling, storage, landing, and catapult launching, thus necessitating a different design. By 1989, the design was narrowed down to two possible configurations, DP-533 with 4 tails and DP-527 with 2 tails and canards. DP-527 was eventually determined to be the best solution. An ATF-23 design was submitted along with the F-23 proposal for a full-scale development, or engineering and manufacturing development. In December 1990, although by late 1990, the Navy was already beginning to back out of the NATF program and fully abandoned it by FY 1992 due to escalating costs. The wind tunnel test model of DP-527 tested for 14,000 hours was donated, with canards removed, by Boeing St. Louis, formerly McDonnell Douglas, in 2001 to the Bellefontaine Neighbors Klein Park Veterans Memorial in St. Louis, Missouri. The YF-23A, internally designated DP-117K, was a prototype air vehicle intended to demonstrate the viability of Northrop's ATF proposal, which was designed to meet the United States Air Force requirements for survivability, supercruise, stealth, and ease of maintenance. Owing to its continual maturation from the HSF concept, which it still greatly resembled, the YF-23's shaping was highly refined. It was an unconventional-looking aircraft with diamond-shaped wings tapered symmetrically at 40 degrees in both the leading edge and back sweep and trailing edge forward sweep. A profile with substantial area ruling to reduce aerodynamic drag at transonic and supersonic speeds, and all moving V-tails or ruddervators. The cockpit was placed high near the nose of the aircraft for good visibility for the pilot, and the chiseled shape of the nose generated vortices to improve high angles of attack characteristics. The aircraft featured a tricycle landing gear configuration with the nose landing gear leg and 2 main landing gear legs. The aerial refueling receptacle was centered on the spine of the forward fuselage. A single large weapons bay was placed on the underside of the fuselage between the nose and main landing gear. The cockpit had a center stick and side throttle. It was powered by 2 turbofan engines, with each in a separate engine nacelle with S-ducts to shield engine axial compressors from radar waves on either side of the aircraft's spine. The fixed geometry inlets were trapezoidal in the frontal profile with spatial porous suction panels in front to absorb the turbulent boundary layer and vent it over the wings. Of the 2 aircraft built, the YF-23 PAV-1 had Pratt & Whitney YF-119 engines, while the second, PAV-2, was powered by General Electric YF-120 engines. The aircraft had single expansion ramp nozzles, or SERN, and, unlike the YF-22, did not employ thrust vectoring. As on the B-2, the exhaust from the YF-23's engines flowed through troughs in the aft deck to shield the engines from infrared homing missiles detection from below. The troughs were lined with tiles built by GM Allison that were transpiration cooled from engine bleed air that to dissipate heat. YF-23's propulsion and aerodynamics enabled it to cruise at over Mach 1.5 without afterburners. YF-23 was statically unstable, having relaxed stability and flown through fly-by-wire with flight control surfaces controlled by a central management computer system, raising the wing flaps and ailerons on one side and lowering them on the other provided roll. The V-tail fins were angled 50 degrees from vertical pitch and was mainly provided by rotating these V-tail... the vertical pitch was mainly... Damn it. Let me just restart that. The V-tail fins were angled 50 degrees from the vertical pitch was mainly provided by rotating these V-tail fins in opposite directions so that their front edges moved together or apart. Yaw was primarily supplied by the rotating of tail fins in the same direction. Test pilot Paul Metz stated that the YF-23 had superior high angle of attack performance compared to the legacy aircraft, with trimmed angle of attack of up to 60 degrees, deflecting the wing flaps down and ailerons up on both sides simultaneously, providing for aerodynamic braking. To keep prototyping costs low despite the novel design, some commercial off-the-shelf components were used, including an F-15 nose wheel, an FA-18 main landing gear parts, and the forward cockpit components of the F-15E Strike Eagle.